Thank you. My name is Peter Heiberg, and I'm working at my day job. I'm working as a consultant at 1347, and I'm working developing enterprise applications. But I'm going to talk a bit about my spare time, where I try to learn more about software development, all aspects, doing advent of code currently. So I've been up early in the mornings. Anyone else doing it? No. I know Miha is, so he switched places with me to be able to finish today's assignment. Well, you can reach me at P. Heiberg at any social media if you have any questions I can't answer now. Also notice I have Pepper's parent here in the image as well. Well, I got interested in machine learning and artificial intelligence, and I started trying to get into the field. I studied engineering back in the university, but I grew tired of math. Everything in the beginning, everything was about basic math, and it got more and more advanced, and every topic involved math, and I grew kind of tired. And when I came back and started to look at machine learning, artificial intelligence, I saw that again. Oh no, it's math. I'm so tired of it. So I gave it a couple of tries to get into the field, but then I kind of just put it on the bookshelf and left it. And then I started to get involved in a spare time project I'll tell you about today. And all of a sudden I discovered a big opportunity to use machine learning and artificial intelligence, and I found that there are people more smarter than me that has already developed the machine learning and artificial intelligence puzzle pieces that could be used. So I'll get into how I got started, and I'll do that by tying back to personal branding and social media. When you look at the topic of machine learning, artificial intelligence, you often need a lot of data to train a model for detecting something. And social media, different social media platforms is where you can find a lot of data. So that's a thankful topic to analyze and capture the data. And I haven't really reflected. What did you do before the advent of social media platforms to brand yourself? In Sweden, there was different publishing houses going around to people and selling books. They published books about people where people could be part of the books and showing what they did on a day-to-day basis, where they got involved in the community, what achievements they had, and so on. This is my grandfather's uncle. He was a woodworking teacher, and he got asked by one of these publishing houses to be part of their book, and they said, "Oh, if you give me a picture of yourself and describe yourself, you can be part of our book, provided that you buy one copy." So he wrote together a short biography of himself. You can find there where he was born, what his parents were named, and so on, and all his different achievements during his life. So turns out this was before our social media bragging, what we did day to day. This was actually something that were present in the 19th and 20th century as well, as part of books. And it turns out that there was a crazy guy called Omar who discovered all these books. He started collecting these books for his local community in Sandviken because he was interested in researching the history of the local community. So he bought lots of books. He started scanning them, cutting them apart and scanning each of these pictures. And he uploaded them to Dropbox and allowed other people to find all these portraits with information on, with little tidbits and pictures of everyone. I'll tie back to this, what this has to do with machine learning and artificial intelligence. I discovered Omars Collection when I was involved in one of my other spare time activities. I do a bit of genealogy, try to find my own history, my roots, and it gets pretty boring with just names and dates. But with Omars Archive, you could actually find the pictures of these individuals and what did they write about themselves? What did they think was interesting to tell to their peers or persons living alongside of them. A couple of developers discovered Omar's Dropbox archive. It was pretty hard to navigate Omar's archive because you had to go into Dropbox, you had to locate your own province, and you had to find them using last name, first name, and birth date. We have a couple of developers, Göran based in Texas, as you can see from his attributes. We have his backend, a very prolific backend developer who's developed a lot of applications for the genealogy community and DNA research community as well. Jonas is a front-end developer from Östergötland. And we have Staffan, who's a statistician from Uppsala. I've never actually met these people. But we've been communicating via social media. They discovered the archive. They created a wiki where people could go in and search. They indexed the portraits using Elasticsearch, so you could search using names and dates, and actually also upload your own family tree using a standard file format from the research program that you can use. I discovered their wiki and I had some opinions. Those of you who know me know that I can't keep my mouth shut. So they got bored. They grew tired of my on my different suggestions. So they said, "Why don't you come and join us and continue developing this wiki?" And I found some improvement areas where you could do something about it. This is what the wiki looked like. You had your portrait containing lots of information. You have the picture, and then you would manually go in and enter information here, extract it from the text, and you would say, well, his first names were Olof Gustav, last name Abelsson, where he was born and when he was born. Pretty much a very manual labor, but it was easy for humans to do this because you can see the text is kind of semi-structured. You can find information there. So it seemed like a good job to automate it. So what you would need to do was to take this text, extract it into a digital format, and somehow try to match the patterns here into different fields. So I started thinking about first developing some kind of just pattern matching, but it turns out every portrait biography for each book was kind of different, and even within the same book it was almost the same, but it was always something that differed. So I started looking into natural language processing and found that there are actually pre-built blocks that you can use to do this. So if we as humans would go in and process this text, we would pick each part here and extract it into one of the fields in the wiki. Some of the fields we need to process further because these are pretty straightforward. But this is a geographic part in Sweden, so we would know that it's Lima parish in Kopparbergs län, which no longer exists. I guess it's part of Örebro. The date formats could differ, so we need to manipulate that as well. Turns out that there is part of Azure where the portrait archive, the wiki, was hosted. There is actually an API for doing natural language processing. I looked into the different Python libraries for doing it, and I looked into the Azure ways as well. And I found Lewis to be one of the ways that I actually could do this. Lewis is a language understanding and intelligence service. It sprung from Microsoft Research. So it's an API-based way of extracting natural language parts. So one way to use Lewis would be to take a sentence that could be from a spoken word that we could translate into text, or just from a picture that we would extract the text, for example. So 100 free tickets from Copenhagen to Prague. So given which context which context this was said in, it could mean different things. So in the context of a booking website, for example, this would mean that the user wanted to book a flight from Copenhagen to Prague. With Lewis, you define an intent. So in this case, book flight, for example. And you define different entities, like the source and the destination and the quantity of tickets. And then Lewis can assist you in extracting this information. So you get the UI in Lewis that's web-based, or you can define it using an API as well, where you get to input some sample sentences and apply the Lewis model on top of it, and you get an output of intents and entities. So given this, I tried to devise a process. How would I do this with a portrait archive? So firstly, we need to take the printed text, the image, and digitize it. And that's a commonplace machine learning technology, OCR, optical character recognition. It's built into the Azure Vision API. So we would then get a text file or a text. We need to normalize this text. So we make, for example, everything lowercase to not have a difference in upper and lowercase, remove periods and everything that's not relevant. And that's built into the Lewis model as well. So we get a uniform electronic text. And we need then to interpret this. So we can train our model in Lewis and have it interpreted into an intent and entities. And then we have to do some post-processing. So for the places, for example, we could look up the places from a defined database of existing places in Sweden. So in Lewis, the interface or where you can define looks something like this. You take a couple of sample sentences and you locate what you want, information you want to extract from one of these sentences. So we mark the last name, first name, the places, etc. And you can also define composite entities, like dates, for example, that can consist of day, month, and year, where some parts can be optional. It's supported in Lewis as well. And some entities can exist in several places, for example. And what you get is when you run the training, you get an endpoint where you can send the text, and it outputs a series of different entities and intents as well. So this is what you get as output if you send in the text to Lewis. You get an intent. And I discovered, first I thought intent is meaningless. I only need one intent. I only want to recognize a text. But then I realized, well, intent, I could abuse that to actually see that different books have different structures. So I could actually make Lewis recognize which kind of book this is. So I started using intents for, oh, this is a book about pharmacists or bakers or whatever. And Lewis could quite accurately predict which kind of book it was that this information was taken from. So we get the list of entities, first names, for example, and the score also, where 1 is being the best and 0 is the worst. That's how accurate this guess is. This is most possibly first names, for example. This is last names, etc. So when applied to the archive, you would first take the image, run an optical character recognition. So this is a workflow. Whenever a new image enters the archive, it's stored in the blob storage and the OCR can be triggered. We would get the OCR text and all the different entities are post-processed, so we would look up the parish against a database of known parishes, for example. The birth date is transformed into a date format known to users with common sense, ISO format. So the users would be presented with a list of suggestions where they could accept or reject each suggestion instead of just manually copy-pasting it, which was an enormous improvement. And also, if you see in the text, it doesn't say anywhere that she's a pharmacist. It says that she's married to a pharmacist. But given the context of the book, Lewis can actually predict that this is the text about pharmacists. So quite an improvement, not very impressive when it comes to what had to be done, but very simple to do because all the puzzle pieces are there already. You can train a machine learning model using just a graphical UI, so very easy to get started with. So some of the others had ideas as well. Staffan, the statistician, he had experimented with face recognition. He started evaluating different methods for doing it. And since the portrait archive is hosted on a virtual machine, we wanted to offload everything to external service because it's a non-profit organization running the archive. It's not a lot of money, so it also goes to the running the virtual machine and first and foremost buying books for Omars so you can continue scanning. So we looked into the different models. We discovered, well, there is a face recognition API in Azure. But it turns out, since the archive is exceeding 800,000 images, which could contain more than one face in each image, it costs quite a lot to do face recognition and pay per call, per face. So Staffan discovered that there is a open source library called dlib for general machine learning, and there are some Python wrappers on top of that for communicating easier. The dlib module comes with a pre-trained model for recognizing faces that's been trained using open source available known faces. So what's face recognition all about? When we look at it as humans, we look at maybe the eyebrows, the ears are very, very special, the mouth, the position of the nose and the shape, etc. dlib and lots of other face recognition algorithms use machine learning, and it uses something called convolutional neural networks, which consists of a series of different feature maps, different layers. So it's essentially a function taking the digital information for the face. Here we have to locate the face in the image, and each of these pixels are fed into one layer that maps one feature and then fed on to another layer mapping another feature and so on. And compared to us as humans doing face recognition, we know we're looking at the nose, we're looking at different parts, but here we actually don't know what layer does what feature is being detected where. But it's been trained so that similar faces give similar outputs, and faces being different give different outputs. So I started experimenting what Staffan has started, and I arrived with a process looking very much like the process for recognizing text. First, we have to locate the faces in the image. And here we can use the face API because locating the face is actually the most processor intensive operation, not recognizing the face, but actually locating it. So we wanted to offload that to the API. So what we would have is an image and the location of the face. Then we can apply the face recognition Python library on top of dlib to arrive at the normalized face image. if face is in different directions, it gives different outputs. So if we capture the face in many different directions and align all faces that they have the eyes in the same position, the nose in the same position, and the same tilt and so on, it gives the best performance. And dlib does this by default. And then we encode the face to some kind of data. dlib and most other algorithms as well encode a face into a vector containing of 128 dimensions, each describing one of these feature maps. So we get a vector of floating point figures. And if you compare these vectors, two of these vectors, if they are close, they're most probably the same face. And if they're distant, they're not. So we get face encoding. And then we need to do this at scale. So we need to, for each of the maybe 1 million faces in the database, we need to compare the face we're looking for with those faces. And this turns out to be a problem because if we're doing it locally, we have to find a mechanism for comparing all the different faces. And I discovered that in PostgreSQL, there is actually a module where you at scale can compare the distance between two vectors. It's called a cube module. So what you can do with the Azure Cognitive Services, the Face API, you can feed in an image and it will detect all the potential faces that are in the image. So in this case, it detects this rectangle here. And you get a position with 4 coordinates. You can also get some other more or less interesting information, a guess on the gender of the person, a guess on the age, which emotion the face has. It's not something that's being used in the archive today. And then using the Python module, we can load one face and we can encode that face into a vector. We can load another face and we encode that face into the vector, and then there is a distance method built in the library that measures the distance, so how similar these faces are. And as I said, with normalization, we can, for one face, we can try to tilt the face in different directions and get the mean between all different encodings for these faces. So for 10 different tilts or twists of the face. What we then do is we output the information to something like this. We have an ID for the image stored in blob storage. And for each face, we have a vector, 128 dimensions of floating point numbers, and the location. And for doing it at scale, I had to reverse engineer. How is this being done in the face distance method in the library? Turns out that it's the Euclidean distance between the two vectors that is a special form of the Pythagorean theorem, if you remember from school, calculating the long side of a triangle using the other two sides, but in n dimensions. You just sum the squares of the differences between each element in the vector. And it turns out that in the cube module in PostgreSQL, that operation is actually built in. So if we have our values that we're searching for, the face coming in here, the encoding of the face we're searching for, we can look into the vectors we have for all the stored faces in the database. And we can look where the Euclidean distance, so how far apart these faces are, is less than a certain difference, or in this case, I just take 1 minus to get a score instead. So 1 being the best and 0 being the worst. And we can set in configuration how the cutoff for detecting these faces, how good the score must be. and turns out that 0.6 or better is actually a very good threshold. So we had some idea to how to use this. First we thought, well, maybe we could just upload our own faces and see if we find something similar in the database. Kind of fun, like on Facebook you get this face test where you see how how similar you are to different celebrities. And that was kind of fun. But then I thought, why not try it for something more difficult? So I started looking at different genealogy groups on Facebook. Turns out that this girl had found a photograph in her grandfather's photo album, and she asked, "Can someone tell me what date this, what time period this was captured? Do you know the symbol here?" and so on. So I tried. Maybe he's in the archive. So I uploaded this photo into the archive. I waited, took some time to process around then, and by then around 700,000 images. And it turns out he had actually used this in a portrait biography. So I got lucky, I guess. It's not percent, it's actually the distance. So 0.6 is turned out to be a good measure of something being, yeah, it could be the same face. So I went back on Facebook and said to her, "It's John Theophil Söderström." "Wow, how do you know that?" And I figured, what should I respond? I'm skillful or no? So I told her we're testing this new functionality in the portrait archive, and I got lucky. It matched him. So I started to get more into this, and I thought I must try this again. Was it pure luck? So there are some groups where people post photos of unknown persons they found in their photo collections. So this woman, she found this person. She knew he might be born in the 20s and around Enköping in Sweden, but she didn't know more. So I uploaded it, and I got hit on someone that was similar, I thought, but I wasn't quite 100% sure it was him. But I posted him and said, "This might be him." And she said, "It's impressive. How do you know that?" And I told her again about the functionality we were testing. And she said, "Oh, the funny thing is, my mother actually knew Gösta Pennycook, who's in this picture. They worked together in Haninge, which is not in Enköping, but close." And then a couple of hours later, another woman turned up, and she said, "Well, my husband knows this man's son." And the son confirms it's actually him in the picture. So I thought, can we do something more with this? And I already discovered that the Army Museum had a large collection of photos. I had been batch uploading all identified photos to the portrait archive, so we would increase our share of photos. And then I found there are a lot of them where it actually says okänd, unknown. So I figured, well, why don't I get started processing these as well? Might get lucky. And it turns out that Krigsarkivet has a lot of photos where these are actually identified. And I started posting on Army Museum's homepage. I posted comments on each photo I found saying, well, this could be this person, and linked to the images in the archive. And pretty soon, Johanna Forsberg, working at Army Museum, came back to me and, "Wow, this is impressive. How are you doing this? We have people sitting here, and we're lucky if we can identify 1 or 2 persons in a month. But you've been cranking out like 100 or 200 soldiers." So I told her about the functionality, and by then we had actually launched it as a membership-only feature. The non-profit organization accepts donations, and also there is a membership fee where you on 120 crowns per year, so it's mostly symbolical, where you get access to some bonus features like the face search functionality. So she actually started searching herself using the face search functionality as well. So it turned out that our fun project identifying faces actually got pretty useful. And I didn't have to use much math either. It was just a Euclidean distance that was provided for me by PostgreSQL as well. You can find the portrait archive here or here. And here is some more information about Lewis and cognitive services and DLib and face recognition as well. Thank you.